Good afternoon. I will present the topic B4E-3 on upgrading the smartness of buildings, including legacy equipment, innovations for legacy equipment. My name is Pierre-Antoine Vernon. I work in the energy unit of EASME. So I would like to start. Sorry, can I have the remote control?
Sorry.
Yes, I would like to start with an overview of issues relevant to smart buildings because they are at the convergence of several trends affecting buildings, energy, and consumers. The first one is at the same time a trend and a challenge. So most of the EU building stock is currently inefficient and will be standing for the next decades. Some of it cannot be renovated using envelope components. Prosumer and energy communities, so innovative smart buildings are already existing, but they are still a minority, so they are far from mainstream. Secondly, Europe has buildings that are already hosting energy-consuming appliances and equipment that were not always designed for energy management. And it's also important to highlight that Europe is perhaps one of the places in the world where you have the most advanced IoT. It is also a leader in in building construction, but also in smart appliances manufacturing. So this is a growth area for Europe in the future. Some of the aspects of energy management relevant to buildings are already existing commercially in other parts of the economy. So, for example, in industry, I'm thinking here of demand response, as well as energy management, mostly for commercial buildings, while the major potential of residential buildings largely remains a potential. Then infrastructure is currently being rolled out in Europe, allowing more and more smart services to be provided. I'm thinking, of course, of smart meters, but also of the future introductions of 5G on the continent. And certainly one of the trends that smart buildings would need to follow is the trend, the consumer appetite for smart solutions improving comfort. For example, in everyday life, I can think of a few innovations in the last years: food delivery, video streaming, dog-free electric scooters, whatever you might think of them. And it comes on the consumer side with commensurate expectations for performance and safety. And last but not least, the public policy is increasingly supporting digitalization, energy efficiency, demand response, consumer rights, energy communities, and building smartness. So, in this context, I will present two topics this afternoon. The first of them being this topic on upgrading the smartness of buildings. Both of them will open on the 16th of July and close on the 15th of January. The topic on upgrading the smartness of buildings is an innovation action. We have 8 million euros for that, so that's roughly enough to fund 2 projects. The second topic is coordination and support action, so not intended to support technology development. And for that action, there is 1.5 million earmarked. That's to say, just enough to fund 1 project. For those who were already here last year, this B4E3 is the follow-up topic to the topic called EE4 in 2019. It is roughly the same action, whereas the B4E9 is a new topic. So the challenge behind upgrading smartness of buildings is largely underpinned by this introduction of a smart readiness indicator, defining smartness as the ability for the building to manage itself and improve its energy performance, interact with occupants and with the grid. So the main objective of the topic will be to improve the energy performance of the EU building stock, hoping that smartness can either complement the current approaches or maybe work where these approaches have failed in the past and maybe replacing them. There is a focus in this topic on legacy equipment. So there is ample detail on the pilots on which I will come back, but legacy equipment should be understood here as energy-consuming equipment that was not designed to be managed, apart from its intended use, I mean, without waiting for the equipment to be replaced. So the scope of the topic. The scope of the topic calls for upgrades, building upgrades in the three dimensions composing a smart building. So building management, support to the grid, and consumer satisfaction. So there is ample detail about the pilots. Maybe the key point to keep in mind is that the pilots should tackle buildings and equipments as they are found in Europe. That's to say heating and cooling, ventilation, lighting, domestic appliances. So we are calling on an upgrade of solutions representative of the EU building stock. So typologies and equipment commonly found there. One specific feature of this topic is the requirement for a very robust commercialization strategy. So securing investment and also targeting large-scale uptake. This is really a topic that is close to the market. And I would like to stress one dimension of the proposals that was maybe insufficiently present in the previous batches of proposals in past calls. That is that the focus on the consumer. Here it would really be important that the building smartness rides this wave of new services offered by widespread IT, communications and big data in order to maximize comfort or user experience. Now a few words on impacts. They are not listed in order of priority, but I will go through them following the list. So the first of them is the primary energy savings. We are an energy efficiency program. These aspects are very important. The second impact is the investments triggered, so both during the project by the actions undertaken and following the commercialization, which is also important. So, of course, depending here on the consumer satisfaction that's achieved through the solution. And the third impact point may be the most complex, actually. It's important to understand it as a smartness upgrade of actual existing buildings, so with potential for replication. A smartness upgrade that unlocks a broad range of equipment and appliances, and a smartness upgrade that involves connecting the devices to energy management systems and demand response. The solution tested under this topic should achieve energy and cost savings that go beyond the energy required by the IT equipment used in the solution. And finally, a horizontal impact on greenhouse gas reduction here should be understood as a reduction of greenhouse gases for heating when applicable from an increased renewable use. And when it comes to air pollutants, I invite you to have a look at indoor air pollution reduction, considering that we work in buildings.